Hello everyone, welcome to my individual recorded presentation on assignment 3 presented by me, Nguyen. And in this video, I'm going to cover all the work that we have done in our assignment 3 with all 6 major sections will also be included in the video. So let's get to the first section, which is to define business objectives. The primary objective of this project is to develop a robust classification model for predicting credit card eligibility, directly contributing to business process optimization, as shown in the figure, which includes efficiency and productivity, cost savings, scalability, improved customer satisfaction, consistency and quality, data analysis, enhanced security, and simplified operations. The objective aimed at the case of customer default payments in Taiwan and compares the predictive accuracy of probability of default among 5 different predictive models. By thoroughly addressing these aspects, the project meets and exceeds the foundational requirements of business optimization, offering a comprehensive tool that impacts various phases of banking operations. Implementing this model significantly improves operational efficiency, customer satisfaction, risk management, and business agility. So in the second section, which is to explore data, as you can see in figure A, we already import the data set into our environment. In the dataset, you can see that we already removed the first row by using Excel because for us, the first row is really not necessary. In figure B, we can see the structure of our dataset by using the function str, which stands for structure, and we can see that the data type of all the variables in our dataset is numeric. First of all, to make it easier to build models later on, we need to transfer some of the variables into factor data type. So you can see in the figure A, we already transformed some variables such as sex, education, marriage, pay 0 to pay 6, and default payment next month to factor data type. As a result, in figure B, we can see a difference in our dataset structure. There are only 15 variables right now are numeric. The other 10 also include our target variable, which is default payment next month, has been changed to factor data type. Next, we need to handle with unidentified data in the dataset. So the unidentified data in our dataset is indicated by the values 0 and -2 in the variables pay 0 to pay 6, as well as 0, 5, 6 values in education and 0 in marriage. So as you can see in figure A, these missing values are now encoded as follows: -1 in pay 0 to pay 6, which indicates pay duly, 3 in marriage, which indicates others, and 4 in education, which also indicates others. Next, it's time for exploratory analysis. Exploratory data analysis in business analytics is an essential process that involves the initial investigation of data to discover patterns, identify outliers, and test hypotheses. So you can see we have identified 6 different charts based on 6 different variables. The charts are created in order to help us to identify any pattern or any outliers. So the 6 variables are sex, education, marriage, limit balance, age, and default payment next month. After having the charts, we get to the first section, preparing data. So first of all, we need to remove any outliers. While inspecting the dataset, the variable limit balance is highly volatile and continuous. This nature means there are many outliers and the distribution of credit values could be highly skewed. Since we use so many models like decision tree, random forest, and SVM, outliers could heavily influence our predictive analytics outcomes. Therefore, we decided to remove the outliers using the interquartile range method, as you can see in the code. Next, we need to upscale the data. As previously observed, there are 6,636 customer records responding yes, and more than 23,000 records had their default payments the following month unaccepted in the target variable, which is default payment next month. So this signals the major imbalance in our data set. So after following the code that we have written, you can see there is a huge difference in our dataset before and after being upscaled. So in the picture on the left hand side is the data set before being upscaled. You can see there is a very huge imbalance between the class 0 and class 1. However, after being upscaled, you can see in the picture on the right hand side, the class 0 and class 1 has shown a very consistent balance. Next, a very important part is to examine the correlation between variables. So correlation coefficient is a statistical measure that describes the strength and direction of a relationship between two variables. So you can see in the image on the left hand side, it shows the correlation coefficient ranking, and the right hand side, it shows the correlation between variables in our dataset. So you can see pay 0 has the greatest influence on the target variable, which is default payment next month, with its correlation coefficient of 0.3985 or approximate 4, which is ranked at moderate to strong, followed by pay 2, pay 3, pay 4, pay 5, and pay 6. So let's get to the next section, which is data sampling. And data sampling plays a very important role in the field of machine learning models, as it ensures a comprehensive and accurate representation of the data, ultimately improving the performance of machine learning models. So as you can see, after getting the final data set from data preparation, we created two types of data sets, which is training data set and testing data set. The training data test is CC train, and the testing data set is CC test. We choose the ratio between the training data and the testing data is 70-30, which means 70% of the data will be used for training and the other 30% will be used for testing and predicting. So as you can see, after splitting the data into training data and testing data, you can see that the CC train has more than 20,000 observations, and the CC test, which stands for the testing data, has more than 9,000 observations. In total, well, there will be 30,000 observations in our data set. So now it has come to the interesting part, which is to build models. So in this section, we are going to propose 5 models, which are decision tree, random forest, KNN, SVM, and logistic regression. So each model in our assignment, in our work, will be trained based on historical data with its target variable is default payment next month, and the predictors are the remaining variables. Once a machine algorithm of each model is learned, they are applied to a testing dataset. To evaluate the performance of each model, metrics like accuracy, precision, recall, and F1 score will be calculated. Let's get started. So our first model is decision tree. A decision tree is a graphical representation used to make decisions and predict outcomes. It is structured like a tree where nodes represent questions or decisions to be made. Branches represent the possible outcomes or answers to these questions, and leaves represent the final decisions or outcomes. Being non-parametric, the technique may effectively handle sizable, complex data sets without requiring a complicated parametric structure. So as you can see, the model is created, visualized, and summarized using the RPart packages. So the model will be stored in a variable called tree model, and then we will use the model to plot the decision tree using the RPart dot plot function from the RPart package. Once we have the graph, we can see the root node of the model splits values using pay 0 as it has the strongest influence on the target variable with its correlation coefficient values of 0.399, as I just mentioned in the previous slides. So in the node 1, also known as the root node, it predicts class 0 with probabilities of 77.7% for class 0 and 22.3% for class 1. For node number 2, on the left-hand side, 80% of the dataset reaches this node with 83% of class 0 and 17% of class 1. It predicts class 0. For node number 3 on the right-hand side, 11% of the dataset reaches this node with 30% of class 0 and 70% of class 1. It predicts class 1. To make predictions, we need to apply the trained model to the CC test testing dataset. The predict function in the rpart package can help us to do this. Once we have the prediction, we can use that to draw a confusion matrix, and then we can calculate the evaluation metrics such as accuracy, precision, recall, and F1 score. You can see the result in the slide. Next, our second model is random forest. Random forest is an advanced machine learning algorithm that builds open multiple decision trees to improve accuracy and robustness, resulting in producing a more reliable and accurate prediction. Combining multiple decision trees to form a forest and make decisions based on majority vote or average prediction. To build a random forest, we will use ranger function in the ranger packages. So the model predicts whether there is a default payment next month based on all columns in the CC train dataset as predictors, builds 500 trees, and is set up for classification. After that, we made the same process as decision tree. We make prediction, and from that we calculated the evaluation matrix for our random forest model. Our third model is KNN. KNN is a straightforward, instant-based learning algorithm used for classification and regression. It predicts outcomes based on the majority vote or average of k nearest neighbors. K values here indicates the number of nearest neighbors to consider when making a prediction. Choosing the right k value is so important for the model's performance. First, we need to build KNN model to predict whether there is default payment next month based on all other variables. So some of the requirement we have set for the model is set k value to 50 and distance to 2. After that, we make a prediction for it, and after that, we calculated the evaluation metrics for it, like accuracy, precision, recall, F1 score. Our next model is SVM. It's also known as support vector machine. It is a very powerful supervised learning algorithm used primarily for classification, but also for regression tasks. It is well recognized for its capacity to function in high-dimensional domains with both linear and non-linear data. It works very well by finding the hyperplane that best separates data points of different classes in a high-dimensional space. The SVM model was trained on the CC train dataset to predict the likelihood of default payment for the next month based on other variables. After training, the SVM model, which used a radial kernel and a cost parameter of 1, included 9,311 support vectors. And then we proceeded to make prediction and store it in a variable called svm_pred. And after that, we calculated the metrics for it, and it shows a very high value for the recall metric. Our last model is logistic regression. Logistic regression is a foundational algorithm for binary classification task known for its simplicity and interpretability. It models the probability of a binary outcome using a linear combination of input features and is effective for problems with a linear decision boundary. Applying logistic regression model to our case, firstly, we need to use CC-train to build model by using GLM function, which is used for linear models. After we have the model, we proceeded to make prediction. After that, we draw the confusion metric and calculated the evaluation metrics for the models. After building 5 models for our project, we proceed to the last section, which is to evaluate our models. So in this section, it assesses the efficacy of the 5 proposed machine learning models: random forest, decision tree, support vector machine, SVM, k-nearest neighbors, KNN, and logistic regression. Accuracy, precision, recall, and F1 score are our four main evaluation metrics that we use to find the optimal model for our dataset. Looking at the comparison table, we can see that GCSN3 it has the highest value in accuracy and F1 score with extremely good precision and recall value. For random forest, it excels in precision, accuracy, recall, and F1 score. For KNN, it has the highest recall but lower in accuracy and precision. For SVM, it has very high values across all measures but not the best in anyone. And for logistic regression, it has a very high recall value and is very competitive in other measures but is not the leader. So based on the analysis, the GCSN3 is the best overall model based on its highest accuracy among all. It also has the highest F1 score, which shows a good balance of precision and recall, as well as highly competitive metrics in precision and recall. However, if prioritizing recall is key, KNN could be a valuable selection despite its lower overall accuracy. For a balanced performance across all metrics, the GCSN3 emerges as a top choice. So in conclusion, this project has successfully developed a sophisticated predictive model that enhances the bank's ability to assess credit card eligibility, improving risk management and customer service efficiency. And our winner is the GCSN3, is the most optimized model based on the model metrics that we had compared in the previous slide. Thank you so much for listening.